Picture this, it's 2025, and the world has gone all in on electric vehicles. Every major automaker is racing to build bigger batteries, faster charging networks, and promises of a cleaner future. Tesla dominates the headlines. BYD dominates the production numbers. Every startup worth its venture capital is chasing the next revolutionary battery technology. But then, something unexpected happens, something that nobody saw coming. A 68-year-old Japanese company with a reputation for elegance and reliability just made an announcement that's shaking the entire EV industry. Mazda just revived one of the most controversial, misunderstood, and abandoned automotive technologies in history, the rotary engine. But here's the twist. It's not coming back the way anyone expected. What is a 50-year-old technology doing in today's modern EV world? The answer might just change everything we thought we knew about the future of transportation. To understand why Mazda's move is so radical, we need to first acknowledge the elephant in the room. Electric vehicles have a serious problem, and it's not what the marketing videos tell you. Yes, EVs are cleaner. Yes, they're quieter. Yes, they're faster off the line. But there's a fundamental challenge that no amount of battery technology has completely solved: range anxiety, charging infrastructure, and the reality of long-distance travel. Think about it. A modern Tesla Model 3 long range offers around 350 miles of range on a single charge. Sounds impressive until you need to drive from New York to Boston or from London to Berlin. That journey requires multiple charging stops, waiting times between 20 and 45 minutes at fast charging stations, and the constant calculation of route planning around charger availability. For millions of drivers, this isn't just an inconvenience, it's a deal breaker. And here's the brutal truth. Simply installing bigger batteries isn't the complete answer. Larger batteries mean heavier vehicles, which means more energy consumption, which means diminishing returns on range. It's a vicious cycle. Plus, battery costs remain stubbornly high. A 100 kilowatt-hour battery can add $15,000 to $20,000 to a vehicle's price. For price-conscious consumers in Europe, Asia, and developing markets, this is a genuine barrier to adoption. Charging infrastructure is still patchy in most regions. Europe has done better than most, but even there, rural areas and secondary cities struggle with charger density. Many apartment dwellers can't charge at home. Long-distance travelers face bottlenecks. And charging times? Even with the latest 350 kilowatts chargers, topping up from 10% to 80% takes time that traditional gas stations made instant. So the industry faces a paradox. EVs are the future, but the current EV formula doesn't solve every real-world problem. Enter Mazda, a company known not for revolutionizing the industry, but for doing things the right way. To understand why Mazda would make such a bold and unexpected decision, you need to understand the company itself. Mazda is not like Tesla. Mazda is not like BYD. Mazda doesn't chase headlines or promise the impossible. Instead, Mazda has built its reputation on elegance, reliability, and finding practical solutions to real engineering problems. The company's philosophy has always been about the joy of driving and doing more with less, maximizing efficiency, minimizing complexity, and creating vehicles that customers genuinely enjoy using. This mindset comes from Mazda's history. Founded in 1920 as a cork manufacturing company, yes, cork, Mazda pivoted to automobiles and, throughout the 1960s, became synonymous with one technology, the rotary engine. While most manufacturers were perfecting the four-stroke reciprocating engine, Mazda bet big on rotary technology. It was elegant, compact, lightweight, and it delivered impressive performance from a small displacement. By the 1960s, Mazda Cosmo and Mazda RX models became icons. The rotary engine was the company's identity. It was why enthusiasts bought Mazdas. It was why the brand stood out in a crowded market. But by the 1990s and early 2000s, the rotary engine had virtually disappeared from Mazda's lineup, a victim of its own fundamental weaknesses and changing market realities. This is crucial to understanding Mazda's comeback strategy. The rotary engine didn't fail because it was fundamentally flawed in concept. It failed because it had real, measurable problems that automotive engineers of that era couldn't adequately solve. First, there was fuel consumption. Rotary engines were notoriously inefficient, delivering fuel economy significantly worse than comparable reciprocating engines. In an era of rising oil prices and environmental consciousness, this was a death knell. Second, thermal management was a nightmare. Rotary engines generate intense heat, and managing that heat without overheating the engine or losing efficiency was an ongoing challenge. Cooling systems had to work overtime, and efficiency gains evaporated, literally and figuratively. Third, emissions. Rotary engines, by their design, had difficulty meeting increasingly strict emissions regulations. The combustion chamber shape and seal dynamics made it hard to achieve complete combustion and reduce harmful emissions. Fourth, durability became a serious issue. The apex seal, a critical component that maintains compression within the rotary combustion chamber, wore out faster than expected in real-world use. Owners reported apex seal failure after 60,000 to 100,000 miles, leading to catastrophic engine damage and expensive repairs. This reputation haunted the rotary engine and, by extension, Mazda itself. Fifth, production complexity and cost. Building a reliable rotary engine required precision engineering and tight tolerances. Manufacturers couldn't achieve the economies of scale that mass production offered with conventional engines. By the early 2000s, the rotary engine was effectively dead. The last Mazda RX-8 rolled off the production line in 2012, and the rotary engine faded from the automotive consciousness, a brilliant engineering solution that couldn't overcome its own limitations. But Mazda never stopped believing in the technology. The company kept the engineering knowledge alive. And as the EV revolution gathered momentum, Mazda engineers began asking a different question. What if the rotary engine's weaknesses didn't matter anymore? What if, instead of powering the wheels directly, it was used for an entirely different purpose? This is where Mazda's innovation breaks from everything else in the industry. Instead of building pure battery electric vehicles like Tesla or hybrid vehicles like Toyota, Mazda decided to use the rotary engine as a range extender, a compact generator that produces electricity to charge the battery pack while driving. In this application, the rotary engine isn't subjected to the same demands as a traditional powertrain. It doesn't need to handle sudden acceleration or deceleration. It doesn't need to deliver peak torque. Instead, it runs at optimal RPM for efficiency and electricity generation, eliminating many of the problems that plagued the rotary engine in its previous life. The light bulb moment came when Mazda realized the rotary engine's disadvantages as a primary power source become irrelevant when it's merely supporting a battery pack. And its advantages, compact size, lightweight construction, simplicity, and powerful to-weight ratio, become critical advantages in a range extender configuration. Before we dive into Mazda's modern improvements, we need to understand what makes a rotary engine fundamentally different from a conventional reciprocating engine in your car. A typical four-cylinder engine has pistons moving up and down in cylinders, creating combustion cycles that convert fuel into mechanical energy. It's the design that's dominated automotive manufacturing for over a century. But a rotary engine, officially called the Wankel engine, works on an entirely different principle. Instead of pistons moving linearly, a rotary engine uses a triangular rotor that spins inside an oval-shaped chamber called the epitrochoi. As the rotor turns, it creates 3 combustion chambers of varying sizes. The rotor completes one full revolution for every 3 combustion cycles, meaning a single rotor engine produces the same power as a much larger conventional engine with a fraction of the weight and complexity. Think of it this way. Imagine a 3-sided triangle spinning inside a perfectly curved chamber. As it rotates, it compresses fuel-air mixture, ignites it, and expels exhaust, all happening continuously as the rotor spins. It's elegant, it's compact, and it's why enthusiasts fell in love with rotary engines decades ago. But here's the critical difference in Mazda's new application. Instead of burning fuel directly to move the rotor and create motion for wheels, the rotary engine now spins a generator. The rotor's rotational energy is converted into electricity, which charges the battery pack and powers the electric motor that actually drives the wheels. This fundamental shift in purpose changes everything about how the engine is stressed, how it needs to perform, and which of its historical problems actually matter. When a rotary engine powered the wheels directly, it had to handle stop-and-go traffic, sudden throttle changes, and variable loads. This is where its inefficiency and thermal problems became critical weaknesses. But as a generator in a range extender setup, the rotary engine can run at a constant, optimal RPM, typically between 4,000 and 6,000 revolutions per minute, where the engine produces the most electricity with the least fuel consumption. The electric motor handles all the variable demands of driving: acceleration, deceleration, low-speed maneuvering, and quick responses. The rotary engine simply does what it does best: spin at a steady rate and produce power. It's like the difference between asking someone to sprint while jumping over obstacles versus asking them to jog at a constant pace. One is exhausting and inefficient, the other is sustainable. This is why Mazda's decision is so clever. The rotary engine's primary weakness, poor efficiency under variable loads, becomes irrelevant. And its primary strength, a high power-to-weight ratio in a compact package, becomes invaluable. A rotary engine takes up about 40% of the space and 50% of the weight of an equivalent conventional engine. In a vehicle already constrained by battery pack space and weight, this matters enormously. Mazda can install a range extender rotary engine without significantly compromising interior space or adding excessive weight. But Mazda couldn't simply dust off a 1990s rotary engine and bolt it into a 2025 vehicle. The company needed to solve the problems that killed the rotary engine decades ago. This is where modern engineering, materials science, and fuel injection technology make all the difference. Direct fuel injection. The first major improvement is direct fuel injection. Traditional rotary engines used carburation or early fuel injection systems that weren't optimized for the engine's unique combustion dynamics. Modern direct injection systems spray fuel directly into the combustion chamber at precisely the right moment with pinpoint accuracy. This solves multiple problems simultaneously. First, it improves fuel efficiency dramatically, often by 15 to 20% compared to older rotary designs. Second, it creates more complete combustion, reducing emissions and allowing the engine to meet modern emissions standards. Third, it provides better control over combustion temperature, which helps with thermal management. Advanced thermal management. Mazda has completely redesigned the cooling system and combustion chamber geometry. Modern computer-aided design and thermal modeling allow engineers to optimize heat flow through the engine while maintaining combustion efficiency. The new rotary engine features advanced cooling channels, improved water jackets, and optimized airflow paths that prevent hot spots where the old engines struggled. Additionally, coatings on the rotor and chamber help distribute heat more evenly and reduce friction. Variable valve timing technology, something that didn't exist in older rotary engines, allows precise control over intake and exhaust timing, further improving efficiency and reducing thermal stress. Apex seal revolution. The apex seal problem was perhaps the most infamous weakness of the old rotary engine. The apex seal is the critical component that maintains compression in the combustion chamber as the rotor rotates. On older engines, these seals would wear out prematurely, leading to compression loss and catastrophic failure. Mazda has fundamentally reimagined the apex seal design. Modern versions use advanced materials, ceramic composite coatings, improved steel alloys, and better surface treatments that dramatically extend seal life. The new seals are more resistant to wear, better at handling thermal expansion and contraction, and more durable under sustained operation. Real-world testing has shown these new apex seals can reliably last for 200,000 plus miles without degradation, a massive improvement over the 60,000 to 100,000 mile lifespan of old rotary engines. This alone transforms the reliability perception of the rotary engine. Precision manufacturing. The original rotary engine couldn't achieve the precision tolerances needed for long-term reliability at the scales Mazda was manufacturing them. Modern CNC machining, laser-guided production, and quality control technologies have completely changed this equation. Today's precision manufacturing can produce rotary engines with tolerances measured in microns, far tighter than the 1990s engines. This means better sealing, less friction, and dramatically improved durability and consistency between units. Variable displacement and detuning. In a range extender configuration, Mazda doesn't need maximum power output. The engine can be deliberately detuned compared to performance-oriented rotary engines of the past. Lower combustion temperatures, lower RPM sealings, and optimized fuel maps for efficiency rather than peak power all reduce stress on internal components and extend engine life. This is a critical insight. Mazda took a performance-oriented engine design and reimagined it as an efficiency-optimized generator. It's the same principle, but the execution is completely different. When all these improvements work together, the results are impressive. Mazda's modern range extender rotary engine achieves fuel economy figures of 30 plus mpg equivalent when running as a generator in the new hybrid electric vehicles. For comparison, a conventional hybrid like the Toyota Prius typically achieves 50 plus mpg because it uses a smaller conventional engine optimized for hybrid duty. But Mazda's rotary offers something different: extreme compactness, lightweight construction, and a fundamentally different architecture that allows for more flexible vehicle design. The rotary range extender doesn't need to be as powerful as a traditional hybrid engine because the electric motor handles peak power demands. This allows Mazda to use a smaller displacement rotary engine, perhaps just 600 to 800 cubic centimeters, that produces electricity cleanly and efficiently while taking up minimal space in the engine bay. What Mazda has essentially done is taken a technology that was abandoned for its weaknesses and transformed it through modern engineering into a solution for a contemporary problem. The rotary engine isn't coming back as a primary powertrain. It's coming back as a specialized component in a hybrid electric system, where its unique advantages can shine without its historical disadvantages mattering. This is engineering innovation at its finest, not inventing something entirely new, but reimagining something old for a new purpose. The question that industry analysts are asking is simple but profound. Why did Mazda make this move now, and why is it so significant? The answer lies in understanding where the global automotive market actually stands, not where the marketing and hype suggest it stands. We've been told that electric vehicles have won, that the future is pure battery electric, that companies investing in any other technology are dinosaurs destined for extinction. But the reality on the ground is far more complex. In Europe, where EV adoption is strongest, penetration rates have plateaued. Yes, over 20% of new car sales are electric, but that also means 80% of buyers are still choosing conventional or hybrid vehicles. Why? Because for many drivers, pure EVs still don't solve their real-world needs. Long-distance travel, charging infrastructure gaps, battery costs, and cold weather range degradation remain genuine pain points. In Asia, the story is different. China leads the world in EV production and sales, but even there, the market is segmented. Pure EVs dominate in cities where charging infrastructure is dense. But in rural areas, secondary cities, and for drivers who need flexibility and long-distance capability, extended-range hybrids and traditional hybrids remain more practical. In North America, the EV adoption rate is slower than Europe's, and customer concerns about charging infrastructure are even more pronounced. The distances are greater. The charging network is more fragmented. The cultural preference for vehicle flexibility is stronger. Into this market reality steps Mazda with a brutally honest acknowledgement. The pure EV strategy doesn't work for everyone, and pretending it does is disingenuous. Instead, Mazda is saying, let's solve a real problem. How do we give drivers the benefits of electric driving while removing their legitimate concerns about range and charging? The range extender hybrid is not a new concept. BMW pioneered it with the i3 Rex over a decade ago. But BMW's approach was to pair a conventional 3-cylinder engine with a battery pack and electric motor. It worked, but it was still fundamentally compromised. The engine was noisy, inefficient, and didn't feel integrated into the driving experience. Mazda's approach is different. By using the rotary engine specifically designed for electricity generation, not for direct propulsion, the range extender becomes seamless and efficient. The driver experiences pure electric driving during daily commutes. The rotary engine only engages when the battery drops below a certain threshold or during highway driving where continuous charging is needed. This means daily driving, zero emissions in cities, no gas engine noise or vibration, pure electric responsiveness. This satisfies urban dwellers and environmentalists who want emission-free driving. Long-distance travel. Instead of stopping for 30 to 45 minutes at a fast charger, drivers can stop for 5 minutes to refuel gasoline. The range extender essentially eliminates the charging time problem. You get unlimited range by refueling with gasoline while still enjoying electric efficiency during normal driving. Cold weather. Battery capacity degrades in cold climates, a serious problem in Scandinavia, Canada, and Northern Europe. With a range extender, cold weather simply activates the gas engine earlier. It's not a problem, it's a feature. Cost. A smaller battery pack means lower cost. A mid-size battery, perhaps 40 to 50 kilowatt hours instead of 75 to 100 kilowatt hours, is significantly cheaper. For price-conscious consumers, this is a genuine game changer. To understand why Mazda's move is so bold, consider Tesla's strategy. Tesla has bet everything on pure battery electric vehicles. The company has no hybrid program, no plug-in hybrid program, and famously, no backup plan. Tesla's logic is compelling. As battery technology improves and charging networks expand, pure EVs will eventually dominate. The company is willing to accept current market limitations because it believes those limitations will disappear. Tesla invests in supercharger networks. Tesla pushes battery technology. Tesla creates vehicles with massive range figures, 300-400 plus miles, to minimize charging frequency. For customers in cities with excellent charging infrastructure and a long-distance travel budget that can absorb charging stops, Tesla's strategy works beautifully. A Model 3 long range or Model S is a fantastic vehicle. But for everyone else, and that's still the majority of global drivers, Tesla's solution is incomplete. Mazda is not trying to outdo Tesla at its own game. Mazda is playing a different game entirely. Instead of saying our batteries are bigger and our chargers are faster, Mazda is saying we've solved the charging problem by eliminating the need to charge as often. Then there's BYD, the Chinese automotive giant and battery manufacturer. BYD does something different. It builds everything. Pure EVs, plug-in hybrids, traditional hybrids, and increasingly electric buses and commercial vehicles. BYD's approach is fundamentally market-driven. The company isn't ideologically committed to one powertrain. Instead, BYD asks, what does each market segment actually need? And then it builds that. BYD's flexibility has made it the world's largest EV manufacturer by volume, not through breakthrough technology, but through pragmatic product selection. Mazda is essentially adopting a version of BYD's philosophy, but with a technological twist. Instead of offering traditional hybrids alongside pure EVs, Mazda is using the rotary range extender to create a middle ground that's more sophisticated than either approach. Let's imagine a European driver living in Germany. She owns an apartment in Berlin with no charging capability. Her work commute is 40 kilometers round trip. She takes 2 long-distance trips per year to visit family in Austria and to vacation in France. With a pure EV, she faces genuine problems. Installing a charging solution at her apartment requires cooperation from landlords and neighbors. Her daily commute requires public charging at her workplace. Long-distance trips require careful route planning around charging networks. With Mazda's rotary range extender vehicle, the situation transforms. She charges at work once or twice per week, something most workplaces can accommodate easily. For daily driving, she gets emission-free electric operation. For long trips, she simply fills up with gas, drives freely, and arrives refreshed rather than stressed about charging logistics. This isn't just more convenient. For millions of European drivers, this is the difference between electric vehicle ownership is practical and electric vehicle ownership is stressful. Now consider a Chinese driver in a secondary city outside Shanghai. Pure EV adoption in these regions lags major cities because charging infrastructure is sparse. A plug-in hybrid that can run on gasoline but also leverage home charging when available is objectively the better choice for that customer's real situation. Mazda's range extender rotary vehicle addresses precisely this gap. Not the best pure EV and not the best traditional hybrid, but the best solution for drivers who want efficiency and environmental benefits without sacrificing practicality. Here's what makes Mazda's move genuinely disruptive. It challenges the industry's unspoken assumption that pure EV is the only legitimate path forward. Traditional automakers, Volkswagen, Ford, Mercedes, BMW, are heavily invested in pure EV platforms. They've spent billions on development and committed their futures to this direction. A successful Mazda range extender rotary vehicle would suggest they bet on the wrong horse. Tesla's entire business model is predicated on pure EV supremacy. A credible alternative that offers practical advantages without sacrificing environmental credentials directly threatens Tesla's narrative and market position. Battery manufacturers and charging network operators profit from the current EV limitation. They profit from having solutions to sell. A technology that reduces the need for massive battery packs and frequent charging directly threatens their business models. This is why Mazda's move is so dangerous to the status quo. It's not proposing a new battery chemistry or a faster charger. It's proposing a fundamentally different path that leverages existing fuel infrastructure, existing engine knowledge, and modern engineering to create something that might actually be more practical for real-world drivers than pure EVs. But Mazda isn't alone in this thinking anymore. Several other manufacturers are quietly developing their own range extender strategies. Chang'an in China has launched hybrid models. Geely is exploring similar concepts. Even traditional European manufacturers are reconsidering their pure EV commitment. The question is no longer will range extenders exist, but rather will they become the preferred solution for drivers who want efficiency without compromise. Mazda is betting yes. And based on real-world driving patterns, charging infrastructure realities, and customer preferences, it might be right. But Mazda's vision doesn't stop with gasoline-powered rotary range extenders. The company has already begun exploring something even more ambitious: rotary engines powered by hydrogen. Hydrogen combustion engines are not new technology. BMW experimented with them. Some concept vehicles have demonstrated the principle. But hydrogen as a practical automotive fuel has never achieved mainstream viability, primarily because hydrogen infrastructure is virtually non-existent, and the challenges of storing hydrogen in vehicles are significant. Yet Mazda is pursuing this path with deliberate intention. Why? Because the rotary engine's unique characteristics make it potentially ideal for hydrogen combustion. A hydrogen-powered engine produces zero emissions, only water vapor. It offers genuine environmental benefits beyond what even pure electric vehicles can claim in regions where electricity generation depends on fossil fuels. It can be refueled in minutes, just like gasoline. And in countries like Japan and parts of Europe, where hydrogen infrastructure is beginning to develop, it's a viable solution. The rotary engine's compact size and high power-to-weight ratio make an excellent platform for hydrogen experimentation. The combustion characteristics of hydrogen are different from gasoline, requiring different engine tuning, but the rotary design's flexibility actually gives Mazda advantages compared to traditional piston engines. This is the crucial insight that defines Mazda's entire approach. The company is not betting on a single technology or energy source. Instead, Mazda is keeping multiple pathways open simultaneously. In the near term, 2025 to 2030 rotary range extender hybrid electric vehicles will address the charging infrastructure and range anxiety problem, offering practical electric driving with gasoline backup. In the medium term, 2030 to 2035, as hydrogen infrastructure develops in key markets like Japan, Europe, and potentially California, rotary hydrogen-powered vehicles will offer zero-emission operation with instant refueling and long range. In the long term, 2035 plus pure battery electric vehicles will likely dominate as battery technology improves, charging infrastructure becomes ubiquitous, and costs decline. But Mazda will have proven that alternative pathways exist and work. This is not the thinking of a company that's lost faith in the EV revolution. It's the thinking of a company that understands a fundamental truth. The future of transportation won't be dominated by a single solution, but rather a portfolio of solutions that address different customer needs and market conditions. Mazda's strategy has implications far beyond Mazda vehicles. The company is essentially saying, we're going to prove that range extenders work. We're going to demonstrate that rotary engines can be reliable and efficient in a modern context. And we're going to show that alternatives to pure EV exist and are viable. If Mazda succeeds, the entire automotive industry will reassess its pure EV commitment. Competitors will accelerate their own range extender and alternative powertrain programs. Investors will reconsider which technologies represent the genuine future versus which represent collective industry momentum. If Mazda fails, if the rotary range extender vehicles are unreliable, inefficient, or poorly received, then the company will have attempted a noble experiment that didn't work, and the industry will continue its march toward pure EV dominance. But here's what's important. Mazda is betting real money, real engineering talent, and real reputation on this. The company isn't making a PR stunt. This is a genuine commitment to an alternative path. Throughout this video, we've discussed technology and engineering. But the fundamental problem Mazda is solving is deeply human: anxiety and inconvenience. A customer considering an electric vehicle isn't asking, does this vehicle have the most advanced battery chemistry? They're asking, will I run out of charge far from home? Will I spend hours waiting at charging stations? Can I take a road trip without stress? Will this vehicle work for my actual life, not just the city driving scenario marketing departments showcase? Pure EV marketing addresses these concerns with specifications: 350 miles of range, 350 kilowatts fast charging. But specifications don't change reality for a driver in rural Montana or a family taking a road trip across Spain. Mazda's rotary range extender addresses these concerns not with impressive statistics, but with practical solutions. It eliminates the charging time concern entirely. It eliminates the range anxiety concern. It allows drivers to use existing gas infrastructure rather than waiting for charging networks to mature. This is why the technology matters less than the philosophy. Mazda isn't saying, our battery is bigger. Mazda is saying, we've solved the problem you actually have. What's fascinating is that Mazda's move essentially gives permission to other manufacturers to explore alternatives. For years, the automotive industry has operated under an unspoken rule: you must commit to pure EV or be branded as backward-looking. But if Mazda, a respected, profitable, engineering-focused company, proves that range extenders are viable and valuable, then Toyota, Volkswagen, Honda, and others will accelerate their own programs without fear of market judgment. The result could be a more diverse automotive future than pure EV advocates expect. Yes, pure EVs will grow. Yes, they'll eventually dominate in developed markets with mature charging infrastructure. But alongside them, extended range hybrids, hydrogen vehicles, and other alternative approaches will carve out substantial niches. This doesn't mean the EV revolution fails. It means the EV revolution is more nuanced and diverse than a single technology narrative allows. If you're shopping for a vehicle in the next 5 to 10 years, Mazda's decision matters directly to you. It means you'll have more options. You won't be forced to choose between pure EV with charging anxiety or traditional gas engine with environmental guilt. You'll have practical alternatives designed for real-world driving. If you're an investor in automotive or energy, Mazda's move suggests that the competitive landscape will be messier and more interesting than simple EV versus gas narratives suggest. Multiple technologies will coexist. Multiple business models will succeed. If you simply care about whether transportation becomes cleaner and more sustainable, Mazda's approach offers hope. The company isn't abandoning environmental responsibility. It's finding a practical path that works for the actual customers and actual markets that exist today, while still moving towards zero-emission transportation. If you want to keep up with the automotive industry's biggest surprises, the technologies that automakers are developing that most people don't see coming, the strategic decisions that reshape the market, and the engineering innovations that solve real-world problems, make sure to subscribe. We break down the stories behind the headlines so you understand not just what's happening, but why it matters. Mazda just did something unexpected. It acknowledged that the future isn't binary. It's not EV or bust. It's not one solution for everyone. It's pragmatic, it's sophisticated, and it's based on engineering excellence and customer insight rather than ideology. The rotary engine had its day. It became a relic. But through modern engineering, genuine innovation and application, and a commitment to solving real-world problems, Mazda is giving it a second life in a completely new context. Whether the rotary range extender becomes mainstream or remains a niche alternative, Mazda has already succeeded in one crucial way. It's forcing the entire automotive industry to question its assumptions about what the future actually looks like. And that kind of thinking, challenging the obvious, exploring alternatives, and refusing to accept simple narratives, might be more valuable than any single technology. If you want to keep watching simple, reliable, and easy-to-understand videos about cars, EVs, new technology, and the automotive innovations that shape our future, make sure to subscribe. We explore the stories that matter in automotive and transportation so you can understand where the industry is actually heading. Thanks for watching, and we'll see you in the next one.